we have a new project. This is our new project. We're using 555 timer and discrete components for making a new project. This is the power LED blue. And what is this? This is the first step in making our project, which is a triangular waveform generator. This is just a first step for making that generator. Let us connect the supply. 5 volts power bank to the circuit. Okay, we have now the power LED turns on, and this output of this circuit, we're going to connect it to the oscilloscope to verify what is this circuit made up of. Let us now connect the probe, positive of the output, and then the negative to the negative. Okay. Open the oscilloscope. Let us take a closer look. What is the output of this 555 circuit? We can see that in the oscilloscope. So that is the output. Some sort of square wave generator, square waveform. Okay. This is the waveform generated by the circuit. Some sort of a rectangular square waveform. And then with the frequency of, let us see, 5.59 kilohertz. Period 0.79 milliseconds. That is the waveform generated by the circuit. Voltage RMS 2.693 volts. Because the maximum voltage peak to peak, this is it looks like a square waveform or a rectangular waveform. 5 volts per division with 5 volts per division. In figure 1, we have square wave generator using 555 timer. So this is the schematic diagram of our circuit using a 555 timer. And we have this power LED blue 4.7K current limiting resistor with the use of 5 volts, that is power bank. So whenever we connect the power, this power LED turns on, indicating that there is now the circuit is on, or we have now the circuit is powering on. The 555 here is what is the configuration or the use of the 555 here. What's the function of the 555 in the circuit? This is an oscillator. So it is producing a square wave or some sort of rectangular wave, continuous on-off waveform. On-off to the output number 3 because we connected the oscilloscope, the positive to the pin number 3, then the negative to the ground. Positive, negative of the oscilloscope. And we have this square wave rectangular waveform output from the pin number 3. So this 555 is configured as an oscillator or square wave generator because it is due to the charging and discharging of capacitor. So you can see here in the pin number 1 is grounded, pin number 2 connected to pin number 6. Okay, and then the capacitor. Pin number 3 is the output, pin number 4 is the reset connected to the positive 5 volts. Pin number 5 control voltage, capacitor 104 or the ceramic capacitor use, and pin number 6 connected is the 10K resistor to the output. So it tends to oscillate because of there is an output and then it going to feedback. This serve as the feedback to the pin number 6, the discharge pin. I think this is the threshold pin, trigger pin, discharge pin. Okay, the output to the input, output input, causing an oscillation due to the output connected again to the pin number 6. So there is an oscillation in the circuit. So the main purpose of the 555 terminal is just a square wave or a rectangular waveform. It looks like a more just like a more on rectangular waveform generator. Okay, due to the charging, while the capacitor is charging, it has an output discharging. There is no output charging, discharging of the capacitor in the circuit. We have now the new circuit. We are adding additional resistor and capacitor, ceramics. 2 resistors and 2 capacitors. And let us powering on the 5 volts. Power LED turns on, and then looking at the, what's this? Oscilloscope probe. So we're going to monitor the input, which is the rectangular wave or sort of a square wave, and then using 2 low pass filter. This is a low pass filter, and monitoring also the output. Looking at the oscilloscope, so you can see here we have this is the input, our square wave. And then the output. We have now the output from channel 2. That looks like a triangular waveform. And as you can see here, this is because of the charging and discharging of capacitor. This one is the charging, discharging, charging, discharging. Let us screenshot the wave and then we are using 2 volts per division. So you can see here, charging up the capacitor, then discharging, charging, discharging, charging, discharging, charging, discharging, causing this square wave, what? Causing the square wave to convert into this sort of rectangular wave. And the frequency is still at, I think it is 4.6 kilohertz, 2 volts per division. Okay, let us take a closer look at this square wave generator using 555 timer. So, in our first step in creating a triangular waveform, we build this oscillator that creates a square wave into its output, pin number 3. So we have now this square waveform output. And our objective is to make a triangular waveform. So we need an RC components composed of 1 kilo ohms of resistor and 103 capacitor ceramics. This is 10 nanofarad, 103, equivalent to 103. And to the second stage of the output is 1K again, resistor and 10 nanofarad or 103 capacitor. What do you think is the configuration of these two circuits or two RC components? This is a low pass filter, LPF, low pass filter. Okay? And our output is connected to the oscilloscope. The positive to the positive, negative to the ground. We're using an oscilloscope for this output. And because of this low pass filter, initially we have this square wave. It takes time to charge the capacitor because of the resistor and the charging capacitor here, and then also again the current flows into here and then charging again the capacitor twice. So now how can we have now this output waveform? How can we derive the output waveform? So from here, capacitor is charging, discharging, charging, discharging, charging, discharging. What is now the output? A triangular waveform. Something looks like this. From a square wave, it becomes a triangular waveform due to the charging and discharging, charging, discharging of the capacitor in the circuit. So we have now the module that could be able to create a triangular waveform. Triangular waveform is created with the use of, why is it that we are using two sets of low pass filter? And why is it called low pass filter? Low pass filter is passing all the low frequency and attenuating the high frequency. And why did we use two sets of LPF to create a steep or a nice triangular waveform. Because in the first set, if we connect the oscilloscope here, the charging is wider. Looks like this. Again, with the use of another sets of filter, it will make this type of waveform now. Instead of a wide form of triangular waveform, steep, slant looking waveform now is being created with the use of two sets of low-pass filter. And what is the usage, or what is the use? What's the function? What's the workings? Why we have this triangular waveform? We just want to learn how to convert this square waveform into triangular waveform, and this circuit is used. There is an application of the circuit for the sound, the electronics or the audio electronics. It could create unique sounds using a triangular waveform. Also in optoelectronics, or in the for the light, it will there's a variation of light flickering. If we're going to apply the principle into the optoelectronics and to the audio electronics, there's some application for this circuit.